Good afternoon, everyone. My name is Vicky Denton. I'm one of the founding directors of the Asian Lubricants Industry Association, and I'd like to welcome you today to our final member-to-member sharing session for 2021. Our topic today is a very, very interesting subject: compatibility testing of marine engine oils. So looking at the literature that exists, there's not a lot in the market about this subject. And we have actually were approached by one of our member companies to hold a session on this to expand the knowledge base that currently exists. So today we're very pleased to welcome everyone who are joining us in this session. We have a panel of experts. I'd like to start with Dr. Khurshid Alam from the Viswa Group, Bienvenido Gonzalez, or Dindo for short, from Sea Oil Philippines, Ryan Neil Delphine from Ocean Tankers Corporation, and Obidur Rahman from Gulf Oil Marine. Welcome to the ALIA member-to-member sharing session, everyone. Before we start, I'd like to talk a little bit about ALIA. We are a Singapore-based nonprofit association to serve the lubricants industry in the region. So the member-to-member sharing is exclusive to ALIA members. And the objective is basically to use this as a platform to share experiences and also knowledge and learnings among members of ALIA. Without much ado, I would like to welcome our main speaker, Dr. Khurshid Alam. Dr. Alam is the managing director of the Viswa Group. He's based in Singapore. Prior to joining the Viswa Group, he served as vice president and regional manager of the Maritime Advisory of DNV-GL. He was also the managing director of Future Ship in Singapore between 2012 to 2018. He served as a director of engineering, energy management, environment, and research development at APL from 2006 to 2012. Dr. Khurshid is a chartered engineer and a fellow of IMAR Est and RINA. He acquired his Bachelor of Science in Marine Engineering from Australia. Subsequently, he received his Master of Science and PhD in Marine Technology from the University of Newcastle. He also received his second PhD in Environmental Science and Engineering from the National University of Singapore. So Dr. Khurshid Alam will be presenting on the main subject of compatibility testing. But before he does, I'd like to invite Dr. Alam to tell us a little bit about the Viswa Group and what it does. Dr. Alam?
Yes, Vicky, thank you very much. Thank you all the participants to take your time to listen to us. Hopefully it will be of some use to all of you, what we're going to present today. I mean, basically the panel will open for discussion so that out of a sort of discussion, maybe something fruitful will come out of it. With regard to Viswa Group, you told me to present about Viswa. Viswa is basically was born as a lab in 1991, and the founder of the Viswa lab or Viswa Group nowadays is Dr. Vis. He used to be a marine engineer, and then he did his PhD like me, and then he was in ABS as surveyor for long, and followed by he joined NASA as a scientist. Then he worked there for quite a number of years, and followed by that he started his own lab, and he thought he could serve the marine industry where he actually came from. And that's how Viswa was born. That was 30 years ago, 1991. And the whole idea came out of his going into this lab business as a passion. That what he himself said, that he suffered a lot with regard to the quality of the oil, especially fuel oil. And then he thought maybe one way or other he could sort of serve this industry by looking at the quality of the fuel and all those, and including lube oil nowadays, that how it can serve the marine community overall. And we have come up a long way. Along the way, we have done a lot of work, especially in R&D, with regard to fuel oil and lubricating oil. We also have come up with like a software that is to do the energy efficiency management system kind of thing, all electronic recording, logbooks and all. And we are involved in many inspection, survey and all this thing, including hazardous material and all the stuffs. So today we are actually quite big, and we are called Viswa Group, not Viswa Lab. And we take pride in, among all the labs in the world, all labs are good, but we take pride that we invest a lot in R&D, including that latest R&D we are doing is on lubricating oil. Our focus is now, we have done a lot on fuel oil, and then the emphasis now we are giving on lube oil and lube oil property and lube oil routine test, and whether it can cover more or less whatever the real need is. All lube oil can perform fine, performance-wise. Again, do you want it to perform better? That is the question. But it is usable. Answer is yes. But the question is it to its best? That remains a question mark. So in that search, we have been doing a lot of work in lube oil. As a matter of fact, I just tell you that we are testing lube oil from different suppliers and then expanding those characteristic or the property of the lube oil, not just the routine test, and then see how does it vary one lube oil from another one, product by product, and then how does the performance wise, be it technically, be it commercially, which one is rather performing one against the other. I stop it here about the Viswa introduction, Vicky. Yeah, thank you.
Thank you, Dr. Alam. With that, let's proceed with a presentation on industry best practice guidelines for compatibility testing of marine engine lube oils.
Thank you, Vicky, again. So I just, when I was invited, I picked up some slides, and I thought, let's start the discussion. That's the whole idea. That is why we did not put that many slides. I think you can see basically maybe the 12 active slides, and one with just an introduction, other one with the end, right? So in that, I'll try to tell you that, as I mentioned, that during my even sailing days, we used to change lube oils one to another supplier, right? It was a very norm thing. I mean, it used to be decided by the office because of commercial reason or whatever it is, and change one to other. And often the question, even as chief engineer, we ask that we are not going to change the lube oil, right? Because take, for example, main engine system lube oil. People never change unless there's a huge contamination or something. Otherwise, the age of the lube oil, main engine system lube oil, it is the age of the ship. That's the way it is. So people just keep topping up as they lose the lube oil because of one reason or other. And then they keep on topping up. But if you look at the DNA of the lube oil, you could find out what is the age of that lube oil. It is the age of the ship. Question is, when we change the brand, one brand to another one, how compatible they are when I'm mixing it, right? I'm not going to empty the tank and putting a fresh oil there. Same thing happens to the auxiliary engine system lube oil. Then if you look at other part of the lube oil, it actually is of concern, is the cylinder lube oil. But that one, you don't have to worry about compatibility, because cylinder lube oil for slow speed two-stroke engine, it is like one-time use and it goes to the drain, right? So you don't worry so much about compatibility for cylinder lube oil. Unless you are doing some kind of blending of the cylinder lube oil, some are tempted to do it to adjust the sort of maybe total base number or TBN kind of thing. Otherwise, compatibility thing in cylinder lube oil, it doesn't matter much compared to the system lube oil, right? So this is one thing I just said that whatever you call the scenario is that the three lube oil you're looking at: main engine system lube oil, auxiliary engine system lube oil, and cylinder lube oil. Main engine system lube oil and auxiliary system lube oil, again, a bit different in a sense. Main engine system basically is a two-stroke engine, right? So two-stroke engine, you have a diaphragm, and on top, cylinder lube oil is taking care of lubricating the cylinder liner and the piston ring, and all the drain goes down to the drain after one-time usage. Then the bottom side, the system lube oil is lubricating the bearings and all those things, including, you can say, the crosshead bearing or whatever it is. These are the bearings basically when rubbing each other, those kind of things. So that system lube oil, it is separated from the cylinder lube oil. There's no mixing unless there's some kind of leakage in the stuffing box and all those things. But these are exceptional things, right? So that's the way lube oil is sort of produced to cater the need, right? So main engine system lube oil is to cater the need of that bearing lubrications and all. And cylinder lube oil, it has other things to do because it has to have many other property like extreme pressure additive and alkalinity of lube oil and all those things, very important, cleaning and all those things. On the other hand, for auxiliary engine system lube oil, four-stroke engine, or is called diesel generator oil, it does the dual function, bearing lubrication plus piston rings and the liner and all those, right? And in that sense, that lube oil is exposed to the combustion, combustion byproducts and all. So in that sense, that lube oil, the way it is formulated, they have to take care of two things: bearing lubrication plus the needs of the ring and liner lubrication. It is again, it is come under different, to some extent, the tribology is a bit different. So it has to cater the need of this in four-stroke engine or that auxiliary engine system I'm talking about, right? So once you set the, and the other oil, just now Vicky was mentioning, like hydraulic oil and stun tube oil, these are not so demanding in a sense. They are more or less performing all right. And compatibility, I don't think it would be of that much interest. People are more interested about with regard to these oils, the system lube oil for main engine system and auxiliary engine system. So without any further, I straight away go to let me expand my PowerPoint. Okay. So when we talk about compatibility, right? As I mentioned, that compatible in what sense? It is no different than the human compatibility, right? Husband-wife compatibility, how compatible they are. You may be compatible in some respect, you may not be compatible in other respect, right? So this is where the dilemma is. You can say overall compatibility, and so maybe yes, it is being used like one lube oil to another lube oil. It is a normal thing, have been going on for quite long, but then they are working fine. But are they working at the best? Answer maybe no. So this is what it is, right? So when we say that, how am I going to see the compatibility? So in that case, I have to really find out, let's do some tests, and what are the characteristics we are looking at for which the compatibility we can sort of compare, right? And that is why you can see that we have done some used lube oil and fresh lube oil. And the scope of testing we have followed, we had been talking about just now before you all came in, different kind of standard, right? You have ISO standard, you have ASTM standard, again, CMAC has its own guideline and all, right? So in the lab, often they go by the ASTM standard. So the scope of testing here, you can see that these are the things we have done. ASTM standards, many of those ASTM standards we have followed. And then when you talk about compatibility, another thing comes in, that is to say, what is the ratio like? What is the ratio like, right? So one lube oil with another lube oil, is it 50-50 ratio or 90-10 ratio or 10-90? You could sort of do a bit more. You can do 70-30 or 30-70. But these are the standard one, 50-50, 90-10, 10-90. So one tells you that, well, it's a little bit of addition, how does it behave? And other one is a half of how does it behave, right? So for each of those tests, we have done this 50-50, 90-10, and 10-90 for new lube oil and in-service oil, right? And what are the things that we have tested? It is here, but I think you will be able to see even in the subsequent slide all the same things again, what we have tested, right, with regard to compatibility. So again, let me put it up front, is that until now, what we have done, we said that something like at what level of compatibility you want to test. Do you want to make it like to the scrutiny should be to the highest, or should it be just a bearable, just acceptable kind of thing, you know? So in that case, we have to have a different sort of standard, different tier level, right? So we say if you go up to tier 1 testing and see whether they're compatible, then maybe one answer you'll get. Then do you like to go further? Tier 2, tier 3, tier 4, tier 5. That means different characteristic will come in, and then see the compatibility of against those different characteristics, right? So let's talk about tier 1. So tier 1, when you do this compatibility test, and then how you do it, the preparation, just like any other, even a university lab, I mean, where I also came from. So you have the processing of your sample, right? So how you do it. So one is by heating, then we do some kind of test. Another one will be doing by incubation, in keeping for some time, and then do the test. And do the test again, 50-50, 90-10, and 10-90. So here I'm talking about the trivial level, tier 1, after heating 50-50 ratio. And you can see that what we check here, the sediment after heating, how does it look like? So green, as you see, that is no sediment, and then very slight sediment, heavy sediment, and appreciably more sediment than 3. You know, so these are the 1, 2, 3, 4. Those kind of index are often used even in compatibility, be it in fuel oil or in lube oil. In fuel oil also there is compatibility kit, and we use a similar thing, 1, 2, 3, 4, 5 kind of range, right? So 0 to 4. And here we found 50-50 ratio for, I mean, one, when we tried used lube oil with in-service, another brand, then we found that, like, say, example, we got 2, like slight sediment is there. And under this tier 1, another characteristic would be like, how does, these are the, like you can see physically, like sediment, other ones, the clarity. How does it look like? Is it cloudy? Is it bright? Is it absolutely bright or moderately cloud? And then goes up to a heavy flock or not. So you can see here 1 to 6, right? So then here we saw is like 2, index is 2, right? So you got sediment is 2, and clarity is 2. Then let's change the ratio for the same oil again, 90-10. And again, in this case, we found no sediment, and clarity-wise is bright, right? And go for 10-90, right? And then again, sediment is slight sediment, and clarity is medium or moderate cloud. It's a 2.5 rather. It's not even 3. So this is tier 1 you have seen after heating. Now let's see tier 1. Again, another process is like after incubation. How does it look like? So similar, again, sort of benchmarking. Sediment after incubation, we found slight sediment, clarity, again, slight cloud, right? That is for 50-50 ratio. Same again goes for 90-10, no sediment, and then quality-wise, bright, 10-90, heavy sediment, the 10-90 ratio, heavy sediment, and medium, moderate cloud after incubation. Right? So this is the tier 1 we have done. Now again, let me summarize. Tier 1 we have done after heating, and we looked at the sediment and the clarity, right? At a different ratio, 50-50, 90-10, and 10-90. Then you want to do the test again with regard to compatibility. Say, how does it look like again with regard to, again, other test methods like a membrane patch calorimetry, this ASTM 7843, and then new oil, there are again that index are there, similar index kind of thing. And then you can see the ratio 50-50, 90-10, 10-90, the result, how it looks like. Again, result is the way it is given is, that pass or fail, pass, fail, and not applicable, right? So, or not attainable. Again, you can see again demersibility. I don't want to go each and every one of it, but again you can see that the membrane patch calorimetry. Then you have demersibility, you have foam sequence and all these things, different ASTM standard, new oil, different ratio, and what the result look like, And at the end, the decision is it pass or fail, right, with regard to compatibility, right? Tier 3 is again go further up, and then you see that, okay, viscosity at 40 degrees Celsius, viscosity at 100 degrees Celsius, how does it look like? And, and viscosity index at, ASTM, the different standard you follow. And then you have, the acid number, all this. And then again, your even phosphorus level, water content, similar thing you do at, following different ASTM standard, and what the result comes out, and then will constitute whether it is pass or fail, right? Again, in addition, you can do further test tier 4 level, and that is the rotating pressure vessel oxidation and the rust, the copper corrosion, all those. And similar thing again, what the result comes out, some are with regard to, in minutes and all, some with regard to, pass or fail. And at the end, the tier 4 test. So we have done this for a couple of clients, and then we found at the end the result is this: new oil in service oil mixture, as you have seen all those I've shown you slide by slide. So it looked like visual assessment after heating for this for tier 1, 50-50 it failed, 90-10 pass, 10-90 fail, and after incubation again fail, pass, fail. So no visual sign of incompatibility was observed, tier 1 test for 90-10, as you can see here, of the new oil, with in-service oil defined by this ASTM standard. So, but 50-50 it failed, 10-90 failed, 90-10 it didn't fail with regard to tier 1 standard. And with regard to tier 2, 3, and 4, then as you can see on the left-hand side, that again, at a different ratio you have done it, right? And demersibility, foam sequence, viscosity at different temperatures, acid number, phosphorus, water, rust, and all those things, whether it's a pass or fail. But as you can see, all of them actually pass, right? So more or less, I leave it here. And this is, I said, to generate the interest about today's discussion. That's it. Thank you. Thank you, Vicky.
Thank you so much, Dr. Alam. Our next speaker is from supplier of lubricants, Gulf Oil Marine. I'd like to introduce Obidur Rahman. Obidur is the technical manager for the Middle East and South Asia of Gulf Oil Marine. He has a bachelor's degree in mechanical engineering from the University of South Australia, and he has a diploma in mechanical engineering from Nghi An Polytechnic, Singapore. Obidur has a certified lubrication specialist certification from the Society of Tribologists and Lubrication Engineers, as well as a machinery lubrication engineer certification from the International Council for Machinery Lubrication. He started with Gulf Oil Marine in 2013, and before that, he was with WES Alliance, which is a representative of Castrol Marine and a Durco fuel oil additive. So without much ado, I'd like to turn over the presentation to Obidur.
Good afternoon. Thank you very much for giving us a chance to join here. Thanks, Vicky, again. Okay, can you share my slides, please? Okay. Okay,
Yes.
the subject we are talking actually today is quite, I will say, quite subjective. We will see why, because most of our lubricant actually we test against other supplier. But let's say if this is not accepted by sometime in certain extent, it is not acceptable by the makers. We have one, so that's why I say this is quite subjective. Although we test our lubricant with independent lab, with that this is compatible, but it is not necessarily that it will be acceptable by other parties. And those tests actually also done under so-called private and confidential term. And also, let me make a disclaimer here. By discussing this topic, we are not promoting to mix lubricant unnecessarily. As our previous speaker said, it is actually sometime in need, or maybe switching over from one supplier to another supplier due to some reason. So whenever the question come, mixing lubricant or switching over from one brand to another brand, few questions come out. And there are some guidance from ISO 55000, which is there are a few guidance. Of course, the best practice is drain, flush, change, followed by drain and change. Regardless, these two are very, very best, the most ideal practice, but it is not commercially or feasible. Even these two ideal practice like drain, flush, change, and drain and change, even the environmentally friendly, it is not an environmental friendly choice. This is because if we change the complete batch of lubricant, when we talk about marine two-stroke engine, the capacity of the oil sum can be like, let's say, from example, 6,000 to 50,000 liters. So it is not practical. Although if we do this, like drain and change, actually we no need to care about all these issues. But it is not commercially viable, also not environmentally friendly, because apart from the commercial, if we change the lubricant just sake of changing the brand, actually we are wasting the lubricant life. And someone may ask questions, if we change it, then it will go for the waste oil recovery, then it will come back to the lubricant again. Yes, you're right. But the problem is, if we want to get back the used oil to recycle it and retrieve back to again to use, we have to, it will come with a cost of dollars and cents plus some emission. So the third choice, which is not the best, but the the most viable option is ruling change. Ruling change actually is mostly for the marine two-stroke engine, some tank, plus we call it auxiliary engine, some tank. So it's like continuously topping up. This is and practically speaking, this is done for most of the customer, and this is a very practical approach. But for doing this, and good thing that for the lubricant used in main engine two-stroke engine, marine two-stroke engine plus marine four-stroke engine, they are mostly mineral oil. So basically, mixing between the mineral oil actually considered as a low risk. Low risk doesn't mean that no risk. So what we have to ensure, there are some guidance to be followed when we switch over lubricant from one brand to another brand. Number one, as I said, we shouldn't change lubricant like today one grade, and next batch another grade, like following another batch. So we should limit the mixing at the first phase. But if we need to mix between lubricants, then of course it has to be equivalent lubricant. That means the grade is number one. If the grade is tested and approved by the engine maker, so it can be equivalent. But if it is not approved by the maker, then it cannot be considered as a used to use apply to the machinery, because lubricant actually we are just lubricant supplier, but the lubricant has to be accepted by the OEMs. We call it like MAN, Wärtsilä, or MEC, and followed by, before mixing the lubricant, we also need to verify whether there is any compatibility report, which was thoroughly covered by Dr. Alam. So this point here, uh, we have to ensure that the lubricant we are intended lubricants that we are going to mix, they are compatible from the lab test, laboratory test result. So, and of course there are a lot of slides we want now, very thorough discussion. One thing we want to highlight here, sometimes it's very difficult to simulate laboratory actual situation into the laboratory. Recently we had an issue. The loops for the new lube and new lubricant, both are equivalent grade, similar grade from the different supplier, is compatible. Then at the elevated temperature, which we call a operating temperature around 60 degrees, they are compatible. But when we reduce the temperature to sub-zero, actually we try to simulate the situations, but we couldn't. There is some limitation even in the lab. Then we made it -10. Then we found that there is some dropout from one additive to another. So the limitation here is, although we of course we have to do the compatibility test from the lab, and we have been doing, but problem is it's very difficult to simulate the actual situation. And another example, recently we did okay, let me put one more sentence here. Most of our lubricant, not most, all our lubricant is thoroughly tested in the field with the field trial with the engine maker. And recently we developed one of the new lubricant. We call it CAT2. That is the um, higher performance grade. When we test the lubricant, I mean, before putting into the engine even for trial, we have to go through sets of tests from the lab, which is guided by the engine maker. And we did the test, all the tests passed with the flying colors. And the test supposed to go for, and we put the oil into the engine, the actual engine, then the test should go for 6,000 hours. But we found that around 2,000 hours, this oil is not performing what we have expected. So engine maker has stopped us and asked us to change the formulations. So basically, what I was trying to say, we definitely need to have the lab report, or we need to go with the compatibility test, but it is not the last one that we can, eye close and use it because it is compatible. And also, we have to check the existing oil, regardless the brand. It can be like we take over oil from another supplier, or somebody taking from us. We have to check the existing oil from the storage tank plus oil in service. We call it used oil for compatibility. And this is one of the industrial practice. And we do test actually various ratio like 1090, 2080, 3070. The most critical is we do the more quite slow interval, low interval, like. But the ideal practice, when you mix into the new oil into the system, we always recommend or limit the mixing between 1090. In other words, if they're using blend brand A now. So if the engine is going to top up with brand B, we recommend not more than 10% at one time. It is also quite practical approach, because if there is any engine come with, let's say, 10,000 liters some tank, so more or less the daily top up is around 120 to 130 liters. So of course, chief engineer in practically they do not top up every day. They do most of the time once a week roughly. So they change or maybe top up 1,000 liters a week. Example. So if let's say if you consider 10,000, 1,000 liter out of 10,000, it is 10%. And if the engine need more oil than this kind of amount, like 1,000, they has to check with something else, because the consumption shouldn't be higher than this much. Okay, this is just example only, not a fixed number. Obviously, we have done some pre-check, then we have carefully added, following some guidance, let's say 1090. It is actually not over. What we need to do during the transition period, we need to actually do close monitoring. There is some, in the engine room, the chief engineer is what is doing, like pressure, temperature, all these they're checking. Of course, lastly, the vibration. So we do not want to go until the vibration, because vibration is the last part. So this is onboard testing, practically, the visuals or maybe some onboard checking. Apart from the onboard checking, we also recommend sending lube oil sample with shorter or reduced interval. According to ISM and many customer, actually they test every quarterly or every 4 months. So during the transition period, that means switching over from one brand to another brand, we recommend at least 3 months or less than that. So at least, or some we have some customer who test at least once a month, at least for 2-3 months during the very beginning of the transition period. So we know if there is any changes in behavior, and we test in the laboratory. Of course, if there is any small sum, it can change completely. But we talk about the marine, is quite huge amount. As Dr. Alam said, actually, other than marine engine oil, other grades are quite negligible. If we consider for onboard oil consumption, almost 85% is taken by main engine and auxiliary engine. Remaining 15% is scattered for all other equipments. It can be stun tube, it can be air compressor or our air conditioning or deck machineries or cranes, all these things. So apart from the mineral oil, those like synthetic or other grades, basically actually we do not recommend mixing between any synthetic oil. We can do the test ourselves, but it will not be acceptable by the other parties. For mineral oil, although people do not make it, maybe subjective, but still there is some industrial practice guided by ASTM, guided by CMAC, and also acceptable by the customer, because just for changing oil, they do not want to throw all the dollars and cents. But for synthetic grade, it is used maybe, let's say, few liters on equipment. So it's easy to change and not very heavy for, commercially is not a problem. So industrial practice that shouldn't mix for synthetic oil, and we also recommend inline with the industrial practice that synthetic oil shouldn't be mixed. And of course, we are just talking about the, other than that, chief engineer need to monitor all this, especially since we are talking about the lubricant and especially mixing. And during this period, chief engineer need to, our onboard engineer, closely look out of the engine operating parameters to ensure that there is no issue between the, lubricants compatibility. Yep, that's my slide. Thank you, Vicky. Thank you very much, James.
Thank you so much, Abidor. I have a lot of questions, but I'm going to hold it. We're going to wait first to hear from our two other panelists. I'd like to introduce Dindo Gonzalez. Dindo is the manager for lubricants technical of Sea Oil Philippines, which is a fuels and lubricant supplier in the Philippines, which is a member of ALIA. So I'd like to introduce Dindo. He's a mechanical engineer with experience in the downstream oil and gas industry and also in the industrial sector. He's been working for Sea Oil Philippines as manager for lubricants technical engineering. He obtained his bachelor's degree in mechanical engineering from De La Salle University. He's a member of the Sea Oil Technical Working Group in charge of transitioning shipping clients to Infinium salicylate marine oil additive technology. Previously, he worked for Chevron Philippines and SK Lubricants, a senior technical engineer. And his co-panelist is Ryan Neil Delphin. Ryan is the technical manager for engineering and maintenance of Ocean Tanker Corporation. Ocean Tankers Corporation is the shipping arm of Sea Oil Philippines. Ryan graduated with a degree in Bachelor of Science in Marine Engineering from John B. Lacson Maritime University in Iloilo. He's a licensed marine engineer. He previously worked for Hartman Crewing Philippines from 2003 to 2013, for Damen Shipyard Singapore from 2013 to 2015, for Kim Hang Marine and Oilfield Singapore from 2015 to 2017, Yanmar Engineering Company Limited in Japan from 2017 and 2018, and for To Go Group from 2018 to 2019. So Ryan's been around the world, or mostly Asia, but he's been around. So I think we're going to really get a lot of hands-on experience from both Dindo and Ryan. Welcome to the ALIA member-to-member sharing session. Dindo, would you like to start off and maybe comment on the presentation? Or maybe you have some questions for Dr. Alam and also for Obidur, and then to be followed by Ryan?
Yes, Vicky, thank you. First of all, thank you for the opportunity to attend this forum. Actually, this is timely that we want to share some of our experience with our customer, especially in the marine shipping industry. I'd like to share one experience we had. This is actually uh, regarding the change of lubricant brand from the previous supplier to the current supplier, which is us, the sea oil company. Actually, the product is of the same product type, which is the mineral-based marine, trunk piston engine oil for the main engine, four-stroke main engine. So what happens is we actually followed the tier one, the tier one compatibility testing, wherein we tested the sediment, and the clarity rating, which actually passed, which means to say both lubricants are compatible. And we also followed the 10%, equal or less than 10% of the change sump tank capacity for each top up occasion. However, we found out that during the operation, after 24 hours, we noticed a formation of sludge, oil sludge, specifically in the storage tank, because we introduced a top up system. We are obligated, we are obliged to do the top up because the owner or the customer itself uh, imposed us to do the top up. No, there is not change oil at all. There's not change oil. Complete change oil is not advised. No, so the customer decided to do the top up. So we follow the equal or less than 10% for each top up occasion, the 10% of the tank capacity. So my question, I wish to direct it to Dr. Koshed. First of all, what could be the possible reason for this, especially the oil sludging in the storage tank? Yeah. Some information about the causes for these occurrences, oil sludging.
Yeah, good. Thank you very much for bringing up the issue.
Yes, doctor.
As I said, tier one, and I have already shown you on case, and sludge formation is one of those things that should be at the back of our mind when we do this compatibility test and all. So, to answer in very brief, what could be the reason? It could be the precipitation of all those what we have in the lube oil, how they form sludge, and as you have seen that again there are two way we look at it, right? As you said, you have done tier one testing after heating. Again, heating has some sort of impact on that whether it will form sludge or not. At the same time, incubation is another one, or rather, taking a bit longer time to incubate and all, and see how they form the sludge. And then you have also seen that some of the tests not done tier one, it is a very, if I have to say, tier one gives you some kind of qualitative kind of result, as you saw, just the clarity and how does it look like and all, and sediment, right? And when you talk about sludge, it could be the formation of the sediment. It is causing the sludge and all, right? So it's a very qualitative thing. But if you don't, that should be the topics of discussion today. I cannot pinpoint what really caused you sludge because we have to do the test. As you have seen, that among the even the viscosity test at 40 degree, 100 degree, VI, many other things come in. And so you have seen tier 2, tier 3, tier 4 goes on and on, right? So any of them could cause many sort of consequences. Could be one of them could be sludge formation. So it's hard to say. So now let's talk about today's discussion. What Ubaidur mentioned is absolutely what is being practiced, and it is your problem you brought up, Ryan, is that we hear that many problem like this. We don't. First of all, you see that lot of things the engine maker, as Ubaidur said, engine maker approve. And my background, you heard that I came from a classification society after APL. I was just like shipping company, then went to classification. Class rule, engine makers that okay to go ahead. These are very basic and very trivial kind of characteristic or parameter they set. As long as you pass that, and should be okay, should be usable. As I said at the beginning, it is usable. The question is, many things, is it really performing to its best? Answer maybe no. Let me bring you to even fuel oil. Fuel oil, again, ISO 8217, basic test. But now we do a lot of tests. In addition to basic test, we do GCMS test, whether there's any contaminant is there, and how a lot of stability issue is there. Stability is again related to this sludge formation, just I mentioned. So all these things, why people do it, in addition to the ISO standard or CMAC standard or engine maker parameter. Why they do it? Because it doesn't encompass all the needed property to do is best. Same like the classification standard, class rule, as you say, class, right? So class rule is the lowest standard, right? Lowest standard. So that is why in the ship, like everything is like under class. Class means you are satisfying the lowest standard, right? Then you are classed. But let me bring it up again. As I said, I came from class. Let's go to offshore. In the offshore, they don't follow class standard. They have their own standard they have set up. They have set up their own standard. That standard is much higher than the class standard because they realize with the class standard, the bare minimum standard is not good enough, right? So they have come to the niche level. They have made the standard much higher than standard. And when class go to offshore, they don't certify. They cannot certify against a standard which is much higher than their own standard, class standard. So they go there as a verifier. That means I'm going to verify against your own standard, you set it there. I hope you get it. So that means to say, offshore industry, they have brought up the standard much higher than the class standard. Class go there as a verifier, not as a certifier. So similar thing here. We are talking about, now I'm trying to summarize with your case and the Obaidur, what you brought up. Should we do this compatibility testing before we change the lube oil? Because you don't change it every day. You change it, maybe normally the contract is for 2 years or something like that. And when you do change, why shouldn't we go more than tier 1 level, right up to tier 4 level, and then have the comprehensive, all whatever you have to know, you would like, you want to know, right? Even as I said, okay, let me give you again another example. That we have tested some of the lube oil in the market. One of the things I have shown is that the demulsibility, the demulsification capability of the lube oil is hardly there. Hardly there. But people don't notice it. It can be used if you don't have emulsification problem. Then emulsification doesn't mean that it has to be milky in color. Then it's too late. That means it's a very minute kind of emulsification that has a huge consequences on the tribology in the lubrication, in the bearings and all, right? And in the gear. So the point is, these are not noticeable things. What you notice is a very gross thing. That means to say, I saw sludge. But many of those things that is impacting the performance of the machinery because of the lube oil, it remains undiscovered. We have seen one lube supplier, the friction coefficient is much higher, much more higher than the worst, than the best one. What does it tell you? Friction coefficient is low. That means to say, I don't have to burn that much of fuel to get the same energy at the propeller, right? Because the friction coefficient is low. But who cares? Who looks into it? Is the friction coefficient good or bad? It's not the engine maker tell you that friction coefficient? No. So this is the commercial thing again you're looking at. You are burning more lube oil, or the friction coefficient not so good, your fuel consumption is higher. Do people notice it? No. Demulsification, do people notice it? Because I don't have emulsification, so I don't know what is the capability of emulsification. So it goes on and on. So engine maker, what they said, so is also the ISO, also the CMAC, they go predominantly very basic parameter to satisfy the basic need, just like the class rule. Question is, should we bring it up higher level of checking so that I know it is compatible or not? Then it may not be of interest to, in a way, to lube supplier, because they say, okay, if it's not compatible, I cannot sell to other clients, right? All this question will come. These are commercial things, how you decide, right? But from the user point of view, if someone wants to be now prudent and say, hey, before I change, you show me the compatibility of your lube oil you're giving me with regard to right up to tier 4. I want to do it. Just like fuel oil testing, ISO never say you have to do GCMS testing. They don't even recognize. But people are doing it because people as end user, they want to know further than what the ISO and the basic need of testing. I did not answer your question straight away. What is the reason of sludge? There could be 10 different reasons for sludge formation. One of them could be the stability, as I said. So the point is that, again, if I could pinpoint that way straight away, I would tell you that, okay, this is the reason and all, right? And that could be a part of the testing. I'm just suggesting that all this should undergo from the user benefit. They should demand before I change. I'd like to see whether it is more or less 90% compatible with regard to the against all the tier 1 to tier 4. But most of the time, as I said at the beginning, and you also said, just people look at the tier 1, this very basic one, how much you would know. I know the sediment, I know the clarity. That's it, right? Okay. Thank you.
Dr. Khurshid.
Yeah, thank you, Dr. Khurshid. My question is actually satisfied with your answer. Yeah, thank you very much.
Thank you.
So that means to say we are indulging to use the tier 2 up to tier 4 to eliminate any hazards for the change of lubricant brand.
Yeah, that will give you good confidence. Absolutely. Yes.
Yeah, I think Dindo, just to share, I think the tier one, tier two, up to tier four testing is like a decision tree risk assessment.
Yes, yes.
So if you fail, if at tier one you fail, then you rule out the that it's not compatible. I mean, you say it's not compatible, and then but if it's good, it's go. Then you do more tests, isn't it? So what you want to see is you need to dig deeper and deeper into
Yeah.
the different tests.
Yeah.
Then after doing all the tests, and I think what Obidor mentioned is also very interesting. You know, they did the compatibility testing at elevated temperature, 60 C. But
Yes.
then when it went to 0 degrees temperature, then there was some additive dropout, isn't it? So
Yeah.
I think you should also bear in mind not only the elevated temperature, the actual temperature that the mixture is going to be exposed at, isn't it? So I think that would be an additional step. Again, if you want to try to avoid these issues, because this costs a lot of money, isn't it?
Yes, that's true.
Yep.
Yeah, even to add on that, May, again, I would say that even the case study I've shown you, very interesting, isn't it?
Mm.
Year 1, 10-90, 90-10, it failed. 50-50, it passed. So you see that when people say 10-90, it should work. Why it came 90? Because this is
Yeah.
from the gut feeling. 10 or 10%, very small amount, it should not cause any disruption, right? So
Yeah.
it's called commingling, you know. So even for fuel oil, we do use the same principle, like either 3% commingling. It's okay. I mean, what can it do? You know, with regard to sort of, because in chemical engineering, concentration times the volume, right? So if the volume you're talking about very small, even the concentration something high is not going to disrupt anything. So from that logic, 10-90 came in. But in that case, you saw 10-90 fail, 90-10 fail, but 50-50 passed.
Yeah, it's
That you did
strange,
the
isn't
test
it?
and 10-90 passed. Yeah, you did it. The question is just 10. How about 12? Maybe it would be different story already. Right? So
Yeah.
binary anyway. Yeah.
Thank you, Dr. Crochet. Thanks, Dindo.
Just the thing is,
Can we ask Ryan maybe to say something, to ask a question to either Obidor or to Dr. Alam?
Yes, thank you, Vicky. Um, I have to address my question to Dr. Korshed. Given all of these good practices and compatibility testing, as all we know, most of the catastrophic failures of marine engines is done by lubrications. Uh, I believe this lowers down if we follow all of these practices. But is there any case or studies that we will still be facing any risk for we are mixing products, another products to products with different additives?
I didn't fully get your question. Sorry about that. You said different additives.
Yes. If we mix both products with different additives.
Different additives. Okay, good question. Yeah. You see, again, now we are trying to go at a DNA level. So when you go to the DNA level of lubricating oil, it's so interesting and amazing. To understand the lube oil, first of all, lube oil constitute of two things. One is a base stock and other is additive. Base stock, it is constituted of base stock. Base stock is around 70% is called base stock. And the 30% is additives. That base stock comes from the crude oil, is the byproduct of it in the refinery process. And the variation of the base stock is so much. I mean, in addition to, I'm saying that I'm in the lab today, but I told me other day that my experience, and then Vicky was there, my experience in APL, I was involved in a lot of R&D work, as you saw my introduction. I have converted one engine even to RTL 96 engine and used three oil majors for lube oil in that engine, and conversion of 250,000 different day tank, and from three different supplier. And then I want to see how does the liner wear again the same feed rate, of different brand for 2 years project. So I learned in that process that base stock quality is number one. Now today we talk about all this compatibility and all this quality wise. If the base stock no good, the lube oil is no good. So that's 70% base stock. Where it come from? As I say, is a byproduct of the crude oil, right? So then again, another the paradox is this. Not a paradox or maybe dilemma, you can say, that if the refinery is very efficient, the base stock, the byproduct comes out for lube oil, it is very lousy. That means they squeeze out all the creams out of it. Your base stock don't have much thing there. And if the refinery is not so inefficient, I don't want to cite example, but say Australian, some refineries are very old refineries, not so efficient. They don't have many other cracking process along the way. So then from the crude oil, whatever they do, that base stock quality is good because refinery is not so efficient to squeeze out the cream. So that base stock quality is good. So now talk about base stock coming from different refinery, different quality. And then Ubaidul is here today, of course, he would know very well. When I check with oil suppliers, I learned a lot from them only, is that base stock, they don't fly. They know the base stock in Australia, base stock is the best. They are not going to fly from Australia to Europe. They will make use of the base stock, whatever available in Europe, right? So that, again, raises the question, how do you then maintain the quality of your base stock? That means it is coming from different source. Your formulation in Rotterdam and formulation in Singapore, you are taking base stock from different source. So your quality also will be question mark. Number two, additives. Around 12 to 13 additives are used in the lube oil. 12 to 13 additives. It goes anti-wear, it goes anti-foaming, it goes dispersion quality, detergents, and all those things. Viscosity, of course, is out there. That rust formation and then oxidation stability. Many things are there. The question is that 13 additives, right? 12 to 13 additives. How much you put in? And then I was amazed. I mean, it's a discussion to again, maybe I'm making it broader, that different oil suppliers take a different position. How they want the lube oil to perform. I give the example. Even in a 4-stroke engine, do you want to have formulated lube oil will give you the least consumption, or will you give some lube oil which will neutralize your carbon deposit more? There is compromise somewhere. So different suppliers take a different stand, not say right or wrong, right? I want to have this one predominant than the other characteristic of the same lube oil. In their own judgment, this is better, right? So in that sense, they won't be same. They won't be same, for sure. Now, the question of additives. Let's talk about base stock. So base stock have different groups, group 1, group 2, group 3, group 4, group 5. One of them, even I'm talking on mineral, then comes the synthetic part of it, right? So group 1 to 4, say, for example, group 1 is not so good, the base stock not so good. So if the base stock not so good, you have to put, if the meat is not so good, you have to put a lot of spices. So that means to say base stock not so good, you have to put a lot of additives, more additives. If the base stock quality is good, group 2, that costs you more, that base stock. But then you don't need that many additives because it itself is good, right? So it doesn't mean that group 2 base stock means that the price of lube oil will be higher, not necessarily, because the amount and the distribution of those additives will be less. So overall, the impact is not so much. So again, end user, you should again ask, hey, you giving me your oil coming from group 2 base stock or group 1, right? So these are the things. So you coming to that level, that DNA level, that how does it really, the lube oil is produced? And then you really say, again, we talk about qualitative risk assessment and quantitative. When I say tier 2 to tier 4, you are going more on the quantitative side. And other one is qualitative. Oh, appearance looks okay. I can see the sediment and all this thing, right? These are very qualitative kind of things. So with regard to now, today's topic is this. What should we do? Should we go for further compatibility tests beyond the minimum what is being practiced today? From an user perspective, I think it is required. That's what I'm trying to say. Yeah. Thank you.
Thank you, Dr. Khurshid.
I have a question for both Dr. Alam and for Obidur. We are only talking about lubricants, but what has been the impact on with the change in fuels, with low sulfur fuels on lubrication?
Again, it's a good question. It's a
Can
very
someone
good question.
comment on
And,
it?
you brought up that again. Maybe I open a Pandora box. I don't know. But you see, this is a good question. Let me answer first. Maybe Obaid will follow up. This is thing I think Obaid himself also is following up very well. I know we are good friends. I know him well. What I'm saying, as a lab, so you see that as we are the third party, we have no interest in all this thing. Where you brought me in, I just told you the interest of different parties because we are the third party, right? When 2020 low sulfur fuel oil came in, and then a lot of machinery problem started happening. So as a lab, and we are, again, somehow I belong to a lab, we promote ourselves, unlike the other lab, they are just a testing lab, they're called, but our slogan is we are problem-solving lab. So we test and give the result, we tell you what potential problem you may have, and we give you the solution for that. So that's why we take pride in that. And as I said, we spend a lot of money in R&D, and we have a full team to solve your problem. So that's why people reach out to us. I have problem with my machinery, and I didn't have this problem before. After using low sulfur fuel oil, I have this problem. So yes, I often say, because I give a lot of talk here and there, often I say, logic comes before engineering, right? Logic comes before engineering. Before 2020, I didn't have this problem. After 2020, what has changed? I changed only the fuel oil. So now I have problem. The problem must lie with the fuel oil. Answer is not right in a way. When we have done a lot of failure analysis, we found fuel oil, yes, you can say that low sulfur fuel oil caused it. It has its own problem because there's a wide variation of the low sulfur fuel coming in from 5 CST fuel oil right up to even order 380, right up to 380. It's wide. They can give you any kind of CST, which we haven't seen before because they adulterate this oil with a lot of different kind of cutter stock and okay, fine. But despite this, when you do many fuel oil tests for those machinery problems they face, we found nothing wrong with the fuel oil. And nothing wrong with the lube oil either. The problem is, this is I try to make it as brief as possible, that it is a catch-22 situation. It's a mismatch of the fuel oil you're using and the lube oil you're using. Mismatch. None of them at fault. So when you go for low sulfur fuel oil, for example, that means you don't have much sulfur now. So the lube oil you have used for, say, before, one of the function of the lube oil has many functions, to transfer the heat, to take the pressure, extreme pressure additive and anti-foaming and all those things. I said carbon neutralization. But among all this property, one of the big one used to be neutralize the sulfuric acid corrosion coming from the fuel oil. So when low sulfur fuel oil came, low sulfuric acid, so you should have low corrosion, right? So that means to say, last time I did not want my liner to be corroded and all this thing. So if the sulfur content in the fuel oil more, I have to put the lube oil with a higher alkalinity, or we call TBN, total base number, to neutralize the acid, right? Acid and alkaline, right? To neutralize. High amount of alkalinity, right? Now, low sulfur fuel oil, we put low alkalinity because I don't need to neutralize that much of sulfur, right? That much of sulfuric acid corrosion. But the problem is this, and that's where the catch-22. The additive predominantly used for corrosion one or anti-corrosion is calcium carbonate. That is one of the common additives used in the lube oil to combat acidic corrosion. But same calcium carbonate is used as additive to get rid of the carbon deposit you have in the piston rings and the liners and all these things. So if you have reduced your calcium carbonate additives and the TBN, they go hand in hand, right? Lower TBN, lower calcium carbonate, yes, to not to sort of overprotect against the acidic corrosion because now your corrosion is less, so you put less additive, low TBN, fine. But it lost the capability of carbon deposit. because the detergent's capability is called detergent. Detergent means like, that you clean, right? Clean the carbon. So that detergent's capability is gone or is reduced, right? And that causes problem. So now how do you live with it? So we realize that you have another variable comes in. You have low TBN or high TBN. Then you can play with another one in chemical engineering. They call volume times concentration. This is the second time I'm repeating it. So if you are feeding the lube oil more of low TBN, maybe it's okay because overall detergent's capability is there because the volume of oil is more. But if you are feeding less, your oil feed rate is less and you have the low TBN, yes, for neutralizing sulfuric acid corrosion, fine, but you can't neutralize the carbon deposit, and that causes problem. So you see, then that means you are now dealing with three variables. And the worst thing is this: no one in the industry can tell you in a regimented way, this should be your feed rate, and this should be the BN you should use. Many cases, end user, they call the engine maker, I have problem with this machinery, tell me, because they are the first one to reach out to. Engine maker come and inspect, and they said, okay, you have this scuffing problem, this, but then you have to try and adjust your feed rate and try BN, what BN to use? From 25 BN right up to 100 TBN you can use, depending on the condition of the cylinder line and rings. This is what the end user get at the end. Why? Because the engine maker themselves do not have any that kind of experience yet. It will take time. Maybe after 5-10 years, they will know. They will know from the users. Many users would feedback. My APL days, I used to feedback my problem to engine maker. From there, they learn, and then they will come and teach you. Oh, this is you should follow. So it is not there. Same, all suppliers also cannot tell you what BN is suitable for you. You see, so this is where, if you ask me now, where are we there? So I recommend at the end users should form their own data, play with your own feed rate, play with your own TBN, and then do under piston inspection and look at it and all those step down analysis and all this thing you do, iron content and residual BN. Then from that, you take care of it yourself and build your own empirical data out of it. And there's no other way. Okay, I leave it here. Let Obaidu say something else maybe. Okay.
Very interesting insight, Dr. Alam. I wonder, Obidor, if you would like to share some of your experience in the last 2 years over the switch to low sulfur fuel.
Actually, Dr. Alam has actually covered comprehensively from the lab to the end. And only I would like to share that actually we actually Bessel are doing scrape down analysis, and every day for the cylinder, and every day we are looking around, let's say 200 reports daily basis. So one very, very comprehensive point is we see using the same lube oil, some engine is okay. Let's say we talk about BLSFO, very low sulfur fuel oil, which is used from since January 2020. So under the same company, same road, they're using 40 BN cylinder oil. One engine has problem, another engine has no problem. Having said that, the fuel also taken from the same supplier on the, let's say, on the same road. So the things we would like to highlight here, and we were actually recommending or maybe talking to a customer or an user, there is no, the rocket science we can give. Okay, this is the engine make, engine model, these are the fuel you're using, this is the TBN or feed rate you use. What we have been following, and even during this pandemic, we are going on board ship, sometime doing the scavenge inspection on behalf of our customer, just to monitor and build database. So we have actually quite many photos taken during this period that, as I said, same lube oil, same fuel, same road, same model of the engine behave differently. And another dilemma, maybe Dr. Alam is very familiar with this. Within the same engine, different cylinder behave differently. We have one recently one study is going on that only one unit has issue. all unit has some kind of, okay, there we call it a cat fine in fuel. So cat fine is abrasive.
Yeah,
The
and it kind of points to me what someone just told me recently, Dr. Boris Schmuth. He says tribology is not an exact science, and I think it's very true what you're saying. We don't have a lot of time left, but
I
I
think,
would like
Vicky,
to
let me just add a couple of sentences, then we will finish it maybe.
Sure.
With regard to what Ubaidu said, and this is very interesting, again, another subject by itself. So when some failure takes place, we do the postmortem analysis. Postmortem analysis. In that, that is why just now I shared with you only lube oil and fuel oil. We don't end here. Usually, when anyone comes to us, my cylinder liner failed, we usually go back to them and say, and that I've been doing even in my past life, even in DNV. Failure analysis, root cause analysis, it has its own way of doing it, not just say fuel oil or the lube oil. So it goes this way. It is we build a hypothesis. Failure analysis must build a hypothesis. What might have caused this failure? So hypothesis matters inform a boundary. It can be because of the material problem, right? Material problem. It can be fuel oil problem among the liquid. It can be because of the lube oil. It could be the maintenance and the operation problem. So you see, what Obadu said, this is the thing we have to understand a bit more. Same fuel, he said, between two sister vessels, it cannot be guaranteed. Same vessel can never lift the same fuel oil. Every fuel oil lifting is the DNA is different. Every fuel oil, even same ship, same port, same supplier is different. Number one. So this variable you cannot say for guarantee. Lube oil, maybe you can say more or less, very close, because same supplier, same brand. But fuel oil, no. Different cylinder, it can happen. It may park under like a maintenance and operation. Other liner wear rate is the same. One maybe 3.5 millimeter, other one maybe 0.5 millimeter, right? Okay. So all these, many things are different. Even the piston ring, for different units and all this thing, how it comes in tribology, right? And it's a very, very complex thing because in the cylinder liner, and it has some kind of hydrostatic, hydrodynamic, elasto-hydrodynamic, and all those kind of things takes place between ring and liner. It's very complex. So having said that, let me summarize. Failure analysis, as I say, hypothesis. So you eliminate one by one, just like the human thing, like if someone has IBS, irritational bowel syndrome, there's no test find it, So that means if you have problem with your gastro, some problem, so they'll be going for gastro test or some kind of, test. They put some tube in your, whatever it is, and then they find nothing wrong. So then if they can't find anything wrong, then they say, oh, you have problem with this, still have problem. That means you have irritational bowel syndrome. So similarly, the hypothesis of this failure analysis, it goes by the elimination process. So we eliminate one by one. For material, we send for the material testing. Oh, nothing wrong. You bought the spare parts from the original maker and everything looks okay. Then let's take the fuel oil. We do extra test, GCMS, this looks okay. Let's look at the lube oil. And that means to say, when it comes to lube oil, what BN you use, and what is do the step down analysis or not, what's the iron content and all these things. Now, how do you operate, right? Then maintenance come in. We take the calibration of the liner and your operation, all these things when you take. So you eliminate one by one, and then you pinpoint that, okay, all those are not possibility. The remaining one must be the one, So it is a very lengthy process. If anyone wants to do shortcut, because of this thing happened, and so maybe it will be the sort of fallacy, not really is true. Yeah. Okay, I just stop it here. Thank you.
I think very good point. I'd like to give the floor before we sign off to Dindo and to Ryan. Do you have any last words, perhaps, to close our conversation?
Yes, first of all, it's very. I'm very grateful for the online. Uh, how do you call this? Guidelines and advice of Dr. Korshed and Mr. Obidur. And I'd like to request if there are any technical literature, especially discussing on the preferred base number for marine oils. for the onset of the 0.5% sulfur fuel oils. Actually, in the Philippines, we are still using the 3% sulfur IFO 180 for the main engine fuels, and we are still in the transition process until 2024-25 before we use by then the recommended base number for that typical level, 0.5% sulfur. So if there are any available technical literature from your side, it will be much appreciated if you can share with us.
So I will do that. I see that, is it Ryan or Dindo yourself most likely Ryan, most likely is with 2Go, right? Is it, Ryan?
Yes, before
Yeah.
Dr. Garcia.
Yeah.
Okay. So you know Apollo Santos in 2Go?
Yes,
Yes.
yes.
Oh.
We're
Yes.
Okay.
they are our clients.
Yeah, he used to be our guy. He used to work for NOL or APL, so Apollo knows
I
me very
see.
well. He was my assistant for long. So what I'm saying, we can share with you. We have, as I said, we are very much in R&D. And then we have technical update time to time, almost like every month, technical update on all those things. Even low sulfur fuel oil, what was the reason, statistical analysis, what we found out, even with the biofuel, what sort of problem you may face and all this thing. So we have technical update. I'll share with you the technical.
Thank you,
And
Doctor.
I think a future subject matter as well that we can cover probably is dual fuels, which is getting more common, at least from what.
Oh yes, very much. Yeah.
Entirely different subject though. So
yeah, it is.
I want to thank all of our panelists, Dr. Khorshed Alam, Dindo Gonzalez, Ryan Delphine, and Abidur Rahman. Thank you so much for participating in this first ever marine engine oil session of Aliyah. And hopefully we can continue the conversation. And before we sign off, I'd like to invite everyone to join us on January 19 for our next member-to-member sharing in 2022. The topic is business challenges and portfolio management during the COVID-19 pandemic outbreak, which will be presented by Mukul Hossain, the Chief Executive Officer of MJL Bangladesh. And on February 22, we have a virtual roundtable discussion on how to accelerate sustainability for the lubricants industry, opportunities and challenges. And with that, thank you so much, everyone, for participating in the panel and also for listening to us. Have a great day.
Thank you.
Thank you.
Thank you,
very much.
Thank you.
Everyone.
Everyone.
Bye.
Bye-bye.
Bye.